All right, this is the first lesson for trigonometry. It's the start of trigonometry. Um, so I'll try to make the notes here as similar as I did in class. So we started by talking about the word trigonometry itself. So the prefix trigono means triangle. And then the suffix metry means measure. So trigonometry talks about the measures of triangles. So you could be talking about side lengths or angles. Okay, so there's three different trig functions we're going to be focusing on. There's sine. This is short for sine. I can write that here. This is short for sine. This is short for cosine. And this is short for tangent. And so those are the three ones we're going to focus on. And we use this acronym SOHCAHTOA, this mnemonic device, to kind of help us remember all these formulas. So you can see the first one says sine is equal to opposite over hypotenuse. Well, that's what this little section is saying. Sine is equal to opposite divided by hypotenuse. Next one, cosine is equal to adjacent over hypotenuse. Well, that's what this little piece is saying. Cosine is equal to adjacent over hypotenuse. And then we have tangent is equal to opposite over adjacent. And that's what this TOA piece is. Tangent is equal to opposite divided by adjacent. So instead of memorizing all these formulas, hopefully you're just able to say SOHCAHTOA in your head. Maybe, write it out on your paper, and that way you can remember these formulas. So I'm going to explain what I mean by opposite, hypotenuse, and adjacent here, but I just want to make sure that you understand how to use the acronym first, because this will not be provided for you. You do have to know how to spell SOHCAHTOA, I guess. Okay, so I give you this right triangle here, and we are going to be dealing with right triangles. By right triangle, I mean there's this 90-degree angle, this right angle. And so hypotenuse should be the side that you're familiar with already. So we know hypotenuse, I'm going to put some notes here. For one, it's the longest side on a triangle. The longest side. And then another fact that some people don't realize is the hypotenuse is always across from the 90-degree angle. So sometimes your triangles won't look so simple like this. Sometimes they'll be really skinny and it'll be hard to tell what the longest side is. So just remember the hypotenuse is always across from that 90. So I'll write that too. Across from 90-degree angle. Okay. So now I want to talk about opposite. Our opposite side is always going to be opposite the angle in question here. So in this case, our angle has this placeholder. It's a Greek symbol. It's called theta. This is theta. And you already know one Greek symbol. You should be familiar with pi, the Greek symbol pi, and now you can add theta. So theta is just used as kind of like a variable for the angle if we don't know what it is. We could easily put x there instead. Any variable will do. It's just commonly we use theta for those missing angles. So that's theta. We don't know what the angle is. But anyway, the side opposite that angle, theta, we call opposite. And that leaves adjacent. So in English, adjacent means next to. And so our adjacent side is right next to our angle, but it's obviously the side that's not the hypotenuse. Some people remember adjacent as being in between the 90-degree angle and our angle, so you could do that too. I always just save adjacent for last. I start by labeling hypotenuse, then opposite, whatever's left is adjacent. That's just how I do it. So it's super important that you know how to label these sides, or else you won't really be successful with trig. So again, here's my process. I just have some random triangles here. We're going to label them opposite, adjacent, and hypotenuse. I always start with the hypotenuse because I know it's across from my 90. It's the longest side. I'm not going to write the words out. I'll just label it H. Opposite is always the one opposite the angle. So there's opposite. and then that leaves adjacent. So you may want to pause the video and try the next three on your own, just labeling them hypotenuse, opposite, and adjacent. But I'll go ahead and do the same process here. Start with H. O is opposite the angle. That leaves A. Hypotenuse, opposite, adjacent. Hypotenuse, opposite, adjacent. And you don't have to draw the arrows every time. Just to begin with, I think it's helpful so you can see how we're labeling these. All right, we're going to start easy here. We're going to start with some trigonometric ratios, trig ratios. So when you hear the word ratios, it could be like something to something, 2 to 3. We're going to think of fractions. Fractions is a way to write ratios. So we're going to write all of these in fractions. So this triangle right here, I'm going to start by labeling my sides. So again, the one across from the 90 is our hypotenuse, the one opposite our angle is opposite, and that leaves adjacent. Okay, and so let's start with sine of theta. That's how we say that, sine of theta. Our angle always goes inside the parentheses. Let's look at our acronym to remember what sine is equal to. Sine is equal to opposite divided by hypotenuse. So coming back down here, opposite divided by hypotenuse, that's going to be 4 over 5. All right. And then cosine is equal to adjacent over hypotenuse. So using these values, adjacent over hypotenuse, that's 3 over 5. And then tangent is equal to opposite over adjacent. So coming back down here, that's going to be 4 over 3, right? Opposite over adjacent. So for trig ratios, we're literally just looking for these fractions so we can see the ratio of the sides for each of those trig functions. So these are, and you can see a question like this on the quiz, you will. It's really that simple. Okay, so now we're going to get into the meat of the lesson. We're going to start by finding missing side lengths, like right here, for these triangles, and then we're going to finish with finding missing angles. So you will need a calculator, and you will need it in degree mode. So I'm using one of these calculators. But for both, any calculator really, you want to go to mode right there and make sure degree is highlighted. Sometimes radians is highlighted by default, so you want to come over and make sure degree is selected. And then you can just go ahead and clear out of that screen. Okay. So for every one of these problems, if we're finding a missing side, missing angle, trig ratios, I'm always going to have y'all start by labeling your sides. So I know across from the 90 is hypotenuse, opposite my angle is opposite, and that leaves adjacent. So we're always going to start by labeling those sides. Now, here's the hard part of these problems. We need to figure out which trig function we're going to use to solve for our missing piece. So we're using sine, cosine, or tangent. That's the question. Okay, here's how you do it. So we have to look at what we're working with. We have the hypotenuse. It's 12. We're looking for x, the adjacent side. O doesn't have anything on it. There's no label. We're not working with it at all. So we're really only working with H and A and H. So we come up to our acronym here, SOHCAHTOA. Which one has A and H in it? Well, it's this one, right? Ka is the only one that has both A and H. And the C stands for cosine. So that's how we know we're going to be using cosine, okay? So that's kind of the hard part, is figuring out which trig function. So I'm going to write cos, short for cosine. And we always put our angle inside the parentheses. So in this case, our angle is 34. You may be wondering where theta went, right? But now we have this number. We know the angle measurement. So that's the same thing as theta, really. Okay, so cosine of 34, that's how we say that, cosine of 34 is going to be equal to something over something. Well, let's remember what cosine is equal to. It's equal to adjacent over hypotenuse. Okay, so in this case, adjacent is x and hypotenuse is 12. So this is equal to x over 12. So that's the setup for the problem. And now we need to go ahead and solve for x. So x is in the numerator of this fraction. We really don't like working with fractions. We want to get rid of it. So to get rid of these fractions, we're always going to multiply by whatever is in the denominator. In this case, 12. And I do that because 12 divided by 12, that's just equal to 1. Those cancel to 1. So now I have x by itself. And remember, if I do that to one side of the equation, I have to come over and do it to the other side. So now on this side, like I said, we're just left with x. And this, we're just going to plug right into our calculator. So we have 12 times. Now you're going to find the cosine button on your calculator. And when you hit it, it should bring up this, cosine with an open parenthesis. And we're just going to type in our angle 34, close the parenthesis, and hit enter. Okay, and you should be getting this. If you're not, just double check that your calculator is in degree mode. Double check that there's not a little -1 symbol here. We just wanted to hit cosine, not second cosine. Okay, and then we want to round to the nearest tenth. So we want one number after the decimal place. So just a rounding lesson, we have to look at the next number, the 4. If it's 4 or less, let it rest. If it's 5 or higher, we have to round that one up. I don't know the saying. So in this case, we're going to leave it as 9.9. And just to be sure, if this were a 5, by the way, we would have to round this up to 10, just so you know. But since it's 4 or less, we have to leave the 9 as it is. But if it were a 5, we would round up to 10. So, okay, so this is our answer, 9.9. Let's go ahead and try this next one. So we're going to start by labeling our sides. You don't have to always go in the same order. I know that's opposite, hypotenuse, adjacent. Okay, so now we have to figure out which trig function are we using. So let's look at what we have. Hypotenuse is blank. We don't care about h at all for this problem. We have A, we're looking for O. So we're dealing with A and O. So we come up here. Which one has A and O? Well, it's this piece. It's the TOA piece. And T stands for tangents. We know we're using tangents. That's how we're going to start. We're going to say tan, short for tangent, of what? What's going to go in here? Well, our angle always goes inside the parentheses. We're going to put 61 in the parentheses. Is equal to something over something. So let's go back up. Tangent is equal to opposite over adjacent. Okay, so that's going to be x over 19. And these problems have been fairly simple because the x is in the numerator. But on the next problem, we're going to see where it's in the denominator what to do. So don't get too confident at this point. You still maybe need to watch the rest of these problems. So again, we have to multiply by what's in the denominator. That way these cancel. And if I do it to this side of the equation, I have to come over and do it to this side as well. So now we just have x by itself like we wanted. And the left-hand side, we're just going to plug right into the calculator. So we have 19 times tangent of 61. So make sure you can find that tangent button. They're all right together, sine, cosine, and tangent. All right, and rounding to the nearest tenth, well, I'm going to look at the number after. That's 7. It's 5 or greater, so I got to round that 2 up to a 3. So this is going to be 34.3. All right, and that's our missing side. These two are fairly straightforward, but that is the general process that we're going to go through. So let's look at the next one. Like I said, there's one additional step here, something you'll run into. So example 4, you may want to put a star around this. I would consider this like a challenging problem, probably like the most challenging problem you would see on a quiz or a test for trigonometry for us. We're going to start the same way. We're going to go ahead and label our sides. So I have hypotenuse, opposite, and adjacent. Okay, we need to figure out which trig function are we going to use. Well, we're missing hypotenuse. We don't know anything about that, but we are dealing with O and A, right? 22 is our opposite side, X is our adjacent side. So which one deals with O and A? And you might need to refer back to the front side, but that's tangent, right? That's the TOA part. So tangent of our angle, the angle always goes inside the parentheses, is equal to opposite over adjacent, right? TOA. So that's 22 over X, opposite over adjacent. So here's where we run into something interesting. In the other problems, the X was in the numerator up top. Now it's in the denominator. But to get rid of this fraction, we always multiply by whatever's in the denominator. In this case, it's X, and that's okay. So they will cancel, but it doesn't get rid of X because we got to come over here and multiply by X, right? We got to do the same thing to both sides of the equation. So the only thing left over here is our 22. I'm going to go ahead and rewrite this so I can stay really organized and be a little extra. All right, so remember, we want to solve for X. We want X by itself. Right now we have X times tangent of 15 equals 22. Well, X is almost by itself, but it's being multiplied by the tangent of 15. So we have to do the opposite. We have to divide by tangent of 15. And you can see when we do that, these are going to cancel out, right? Something divided by the same something cancels to 1. So now I have X by itself. But I can't just do this to one side. I have to divide both sides by tangent of 15. Okay, so now we have X by itself. And we're just going to put this part in our calculator, 22 divided by tangent of 15. And you should get, oops, that is not what I wanted. I'll have to change my mode. Your calculator should be fine. Mine's just being weird. 22 divided by tangent of 15. There we go. So rounded to the nearest tenth, that's going to give us 82.1, right? If there's a 0 after, we're just going to leave that 1 just like it is. So 82.1. Okay. So that was solving for missing side lengths. Now we're going to go to missing angles, which most people find a bit easier. And we're going to start the same way. These problems are very similar. We're going to label our sides. So now we have theta back again because we're trying to figure out what that angle is. We don't know what it is. Okay, so let's see. 20 is our hypotenuse. This will be opposite. And then we have adjacent. So again, we want to figure out which trig function we're using. We don't have an opposite side, but we are provided the hypotenuse and the adjacent side. So which one deals with A and H? Well, that's this piece, and the C stands for cosine. So we know we're going to use cosine. So I'm going to say cosine of, well, what's going to go inside our parentheses? It's always the angle. So in this case, we'll be working with theta. So I'm going to put theta there. Cosine of theta is equal to adjacent over hypotenuse, right? It's still coming from the acronym. Cosine is equal to adjacent over hypotenuse. Okay, so in this case, that's 13 over 20. We're not just going to stick that in the calculator. We're trying to solve for theta, but it's trapped inside this cosine function. So to get it out, we want to take the inverse of cosine. So it's going to look like this. Cosine with a little -1 up here. And to find that on your calculator, we're going to have to hit second cosine. So on most people's calculators, if you look right above the cosine, see how it says cosine with the little -1? That's the inverse of cosine. So to get to it, we hit second cosine, and it'll open up this little screen right here. So now we're just going to type in our ratio, which is 13 divided by 20. 13 divided by 20. And that gives us theta, our angle. And we're going to round to the nearest tenth, so that's going to be 49.5. So theta is equal to 49.5. And I'm going to go ahead and put degrees. That little symbol right there, that little circle is degrees because we are talking about angle measurements. And that's how all of these work. So let's do these next two. Label my sides. We got opposite, hypotenuse, and adjacent. So here we're working with opposite and hypotenuse. You'll notice the adjacent side is blank. Okay, so opposite and hypotenuse, you can flip over and check your acronym, but that's going to be sine. So we're going to say sine of our angle theta is equal to opposite over hypotenuse. So 7 over 27. And again, we're trying to solve for theta, but right now it's trapped inside of this sine function. So to get to it, we're going to take the inverse of sine and just type in our ratio. So on your calculator, you're going to hit second sine and then just type in 7 divided by 27. And that's going to give us 15.0, or just 15. So theta is equal to 15 degrees. And you may want to pause this and try the last one on your own, but I'm going to go ahead and do it. So let's see, we have hypotenuse, opposite, adjacent. We are working with O and A. H is blank, so we're only dealing with O and A. You can look at your acronym, but that's tangent. So tangent of our angle is equal to opposite over adjacent. Remember TOA, opposite over adjacent. So that's 58 over 75. And to get to that theta, we're going to have to take the inverse of tangent and type in our trig ratio. So let's see, we're going to hit second tangent. 58 divided by 75, and that is giving us 37.7, right? Since there's a 1 after, we're just going to leave the 7 as it is. So 37.7 degrees. And that's it.